Hey there, welcome to this on-demand session on my talk on real-time pneumonia detection using ML, Docker, Balena, and Edge Impulse. Before I start off with the talk, who am I? So I am Arijit, a 15-year-old from India. I am an ambassador for Edge Impulse, which is an embedded machine learning startup based in San Jose. I am the co-organizer for TinyML India and the lead organizer for TinyML Aspirants community. For questions related to this session, please feel free to connect with me on Twitter and LinkedIn with the handles shown here. For the agenda of this presentation of this today's talk will be sharing about the problem statement and then sharing on how we can solve it, plus accompanied with a live demo and conclusion and resources of the main talk. Pneumonia is ultra troublesome. Pneumonia has troubled the world for decades, with deaths mounting when early detection is missed. The WHO estimates that each year the number of people affected by pneumonia is nearly 450 million, with the number of deaths reaching around 4 million per year, mostly in the developing world. These numbers represent a lot of pain, lost dreams, and grief for people everywhere, and can be mitigated. Pneumonia detection can be out of reach for many. So far, the detection of pneumonia is achieved by using X-rays, chest scans, or extracting blood serum in severe extreme cases. But this requires time, resources, skilled personnel, and is quite expensive. How can we solve it then? Are there any possible measures that we can take to solve this problem? Sure, it is. We can solve it using a tiny ML. Embedded devices are everywhere. They are around 30 billion in number as per a survey done in 2019. So embedded devices are those devices that have no internet connectivity. They have around a flash of less than 1 megabyte of RAM and few kilobytes in storage, and they only consume energy in a few milliwatts. And embedded devices are the main key concept, are the main key hardware devices that are being used for deploying tiny machine learning models on them. Solving for the cost, location, and speed will definitely save lives. I've been working on a solution that harnesses low cost hardware and software that can deliver effective detection for people everywhere, regardless of the location, skill, and affordability for detection of pneumonia. With the help of software such as Ajumpers and their hardware partners, I can show you how to effectively detect an alert of potential pneumonia. So, stuff that we need for this today's demonstration are a Raspberry Pi 4 or a 3 or a compute module, and we need accessories for them. And on the software side of things, we will have to use Balena, Docker, and Edge Impulse. Alright, so I gave a quick intro into what is our problem statement and kind of a solution to it. So let us have a look into the demonstration to get to know further about the project. So this is the main dashboard that I have in Edge Impulse Studio, and I have then just created up a project with the name Pneumonia Classifier. And when I head over to the data acquisition page, I have collected around 4000 items, which are the 4000 images of various different types of chest x-rays for my training dataset. So I have 1200 images of the viral chest x-ray and around 1300 images of the bacterial chest x-ray and around the same of the normal chest x-ray as well. So these are some of the example images that I have for the trained data set that I have. I've collected around various different images of the same. For the test data set, I have around 1000 images of both viral, bacterial, and normal. So I have now created up my impulse, which is the ML model that we have, and I have added a processing block of image because we are using an image classifier model in over here, and I have used a neural network keras for making our ML architecture. In the neural network architecture, you can see that this is the main entire code that we have for making our ML model, and I have got an accuracy of around 78%, which is pretty good in considering the amount of datasets that we have fed into the model. I have then retrained up the model, and I have then successfully, like I can say that my model has been successfully trained. It is now 100% complete. Alright, so I will go back. So this is the page that I have, which is the GitHub repository, and if you scroll down to it, you can get to see that there is this tab saying deploying the code on Balena. And Balena has interactions with GitHub, which then uses any kind of sort of this deploy with Balena buttons, and then that deploys the entire GitHub repository with the help of Docker files onto Balena, and then that runs onto our single boot computers. So if you click on deploy with Balena, it then just opens up our Balena dashboard, and you need to create an account if you don't have one. And I will click on create a new fleet, and let us say this to be Pneumonia, and I will choose a device type, which is Raspberry Pi 4 using 64-bit OS. Yes, and I will click on create and deploy. Alright, once done, we get to see that it says our fleet with the name Pneumonia successfully created, but it doesn't have any devices connected to it. So what I will do is that I will click on add the device option, this tab, and yes, we will be using a Raspberry Pi phone in over here, and I will click on development, but you can use production images as well. Now for the network connection side, you can either use Ethernet only or Wi-Fi, and over here I will be using Wi-Fi for an instance. And then you just click on download Balena OS, and then you flash on the device with the help of Etcher. Directly just put in the SD card into your laptop or the computer, and you then flash the entire image onto the SD card and plug it into the single board computer. So I've followed all the steps, and my device is now being successfully connected to both Balena and Edge Impulse dashboard. And once it is done, it then just runs these two containers, which are Balena Cam and Edge Impulse inference containers. So once it is done, it will see in the logs that connect your device using a public device URL or using the local IP address to get to see the live the live dashboard that is coming in from the camera feed connected to the device. So I've copied the local IP address and I've pasted it in over here, and this is the the local camera feed that is coming from the device, and we can see that it says it is a bacterial pneumonia with 99.6% accuracy, which means that this chest x-ray is a bacterial pneumonial chest x-ray with 99.6% accuracy as set out by our ML model. Alright, so that was a pretty neat demo from my side. So conclusions for this talk, we are using state-of-the-art AI algorithms for usage of TinyML model. As we are using TinyML in over here, the device becomes ultra low power and is ultra cost efficient. And with the help of user-friendly UI UX designs, we can support more than 5 different types of hardware categories with the help of Edge Impulse. And we can even see that our ML model provides results with an accuracy of around 80%, whereas on the same hand, doctors can only provide up to 30%. So, resources, you can check out the entire blog post containing the detailed links to everything with all of the hardware and all of the software supported, and steps on how you can follow and develop the same of your own. Plus, you can check out our GitHub repository for having a look into the source code and what is running behind all of that you see here. Alright, so that was it from my side. Thank you so much for listening to my presentation, and if you have any questions, please let them know.